The fun bit is the prediction. The fun bit is the getting the answer with confidence, okay?
Isaac Anoom, Mr Numbervator, was invited into Mount Pleasant Lane School to take a Year 6 class in algebra.
Let's shake hands. How many handshakes can 2 people make? One, okay? Right. If there's 3 people, how many handshakes can 3 people make?
Isaac, we asked you to do a lesson on algebra. How did you think that the handshake problem addressed the issues?
What I was looking at was this idea of pattern spotting and the fact that the children were able to sort of record their observations and then actually identify the pattern, explain the pattern and talk about the pattern. And so that was my way into the actual session and lesson itself. 4 people, how many hands? 8. How many handshakes? 6. Right. Look at what I've written on the board. Can anyone have a little think? We know this column here. We know that we're doubling because this boy here said we're going to times it by 2 because of the number of hands. But look at this column here. Can anyone see what is happening here?
It's adding 1, then adding 2, and then adding 3.
Right, so Sammy then, can you tell me if I have got 5 people, how many hands will there be?
10.
The number of handshakes will be how much then?
10.
How do you know it's going to be 10?
Well, because you've added 1, then you add 2, then you add 3, so you must add 4 on to 6, which will make 10.
Right, excellent answer. Well done. The problem is I need to know how many handshakes will 10 people make, and 15, and 20.
I love their different methods of recording. If you notice, some of particularly the girls, were perfectly neat in their recording. And the boys who grasped the pattern spotting immediately simply wrote the answers and simply wrote the list as it went through to get it. But what interested me most was the young boy who thought he came up with a generalisation that he could double the pattern.
Yes.
And I found that fascinating, and I particularly loved the way you handled that.
Once I got to 20, I just doubled it to 40, then doubled 40 to 80.
Right, so do you think we're just doubling all the time?
Sometimes.
Right, what was the answer for number 5? 5 people, how many handshakes?
5 with 10.
Right, so if I double the answer for 5, is that, what's your answer there for 10? So it's not doubling, is it?
No.
No, but listen, you had an idea, we tested it out, it didn't work, so now you can move on again independently, can't you?
Yeah.
And he didn't feel that he was wrong, he didn't feel that he was made a mistake or someone was going to look at him. He just knew automatically they had to go back and revise his answer.
And that's the sort of thing I want to encourage within the class, that the children are aware that they are allowed to make mistakes because they will learn from those mistakes.
Right.
And it's the children that made the mistakes that were determined to go on and succeed.
The other thing I noticed was that the children were all incredibly quick at observing the pattern and then repeating the pattern on their whiteboards. But you stopped them at one stage because in order to get them to think algebraically, you were wanting them to go to the next level, and that's when you brought them out to the front and used them physically to get the task of the observation that if there were 6 of them, the pattern would go 5 plus 4 plus 3 plus 2 plus 1. And that generated something which was really exciting. Do you remember that, David?
Yes, the one that said, oh, it's -1.
Fantastic.
Ah, yes.
And he took one step towards algebra.
Yes.
Well, since you've already, you've missing one child, he won't count himself, so every time he'll go around, he'll be missing, himself, so each time it'll go -1.
It's always going to be -1. So -1 is coming to this. So it's always going to be -1. We're looking at number. We're looking at algebra. And when you mentioned -1 to me, this is what comes into a natural equation. Okay, it comes into algebra. You are talking in terms of representing numbers with people and people with numbers.
As a Year 6 teacher, David, do you find teaching algebra tricky?
I think there are those at the top of the group who will find it great. They love it. They enjoy it. They want to get involved. They know it's the next step for them. And there are those that towards the middle and the lower end of the group who find it really tricky to grasp the idea. But I think by applying it to this idea of a pattern, then they will be able to think to themselves, okay, it's not just n we're putting in n because we don't know what number it is, and if we applied it to this pattern each time, we could find the answer in every occasion. I think they will link the two in much better now.
So I think that there's quite a bit of work that needs doing on certainly the empty box bit of much lower down the school, so they get used to that, so that they're not always going to know a quantity. So once you've progressed them from the empty box, the spotting of patterns, the coming up with predictions, the generalisations, the moving into the function machine where they're giving you a rule, and once they can spot the rule that's happening, then I think we're on the way to making algebra easier for children to grasp.
Definitely.